Hi, this is Varsha, and here is my demo of Lenny Growth Assistant. This is an AI-powered conversational assistant designed for growth practitioners or product managers. The core brain of this is powered by the insight from 303 Lenny podcast, and it allows user to query multiple complex question and generate essay and build a visualization in a single dashboard. So the front end is built using React and the back end using Fast API. It handles streaming of LLM responses via server-sent events, and it allows communication between multiple LLM providers like Anthropic, Cerebras, and local Olama. Coming to database, I have used Supabase, and here it consists of four main tables like messages, session, artifacts, and transcript chunks. Messages and sessions handle in turn chat history, and artifacts stores the generated HTML document, and transcript chunks. Here we ingest the transcript of 303 Lenny podcast and chunk them and store them as 768 dimensional vector images. So coming to agentic routing, so when a user types a question, the system has to know whether to run a rack pipeline or to generate artifacts. So I have used a three-tier smart router to handle this. The first tier is the Anthropic. Here I have used Cloud and explicitly set the tool choice, and this forces the LLM to generate a structured JSON output for the tool call. So this knows whether to call a rack pipeline or a content generation or a visualization tool. Now, if the Anthropic fails or the user toggles to Cerebras, it automatically falls back to the Cerebras and performs its tool call. Now, tier three is the local Llama. So the smaller local models like Llama is unreliable to routing. So I have used a four signal weighted ensemble. So it combines semantic similarity, context continuity, function calling, and keyword baseline. All these run concurrently, and it then casts a weighted vote and confidently route to users' requests. So, for example, I'm choosing a local model. So the local model goes through the weighted voting and it chooses the appropriate tool call. Here for this prompt, it chooses the rack pipeline and it goes through six stages of retrieval. It has produced the answer and it finally also generates a knowledge graph. So it has generated a knowledge graph for the retrieve the context. It now chooses the context generation tool calling, content summary of 1250 words. Here's the HTML document that has been generated. So here is the visualization of retention coherent chart. Finally, I've also deployed it on Railway. For example, here's the funnel visualization. Here I have deployed embedding model because other models might take a lot of time to again process the embedding. So I have deployed it on Railway, and here's the entire deployment of the application. Thank you.